Hi, in this video we're going to factorise a quadratic expression where we can make a substitution to make our lives a bit easier. Now if we look at this expression here, can you see that this x plus 2 is common here and here, right? And it looks a bit quadratic-y because we have 9 times something squared plus 6 times that same thing and a constant term at the end, like a number, right? So what we could do is, because we have this x plus 2 common here and here, is that if we just replaced the x plus 2 with another variable, like say y, it simplifies expression to make it easier to factorise. So let's say we're going to let another variable, let's say y, just because y is after x, be equal to x plus 2. Then we can just replace this x plus 2 here and this x plus 2 here with y. We can substitute it for y. So if we do that, we now got 9y squared plus 6y minus 8. And that's great because we've now got a more traditional quadratic, which in previous skills we've seen how we can factorise. So let's remind ourselves how we factorise this. We need two numbers that add to give the middle number of plus 6, the coefficient of the y term or the x term, whatever you have, and they multiply these two numbers to give the first times the last number. So 9 times minus 8 is minus 72. So we need two numbers which add to give 6 and times to give minus 72. Well, what numbers multiply to give just 72? Well, it's 12 times 6. But one of them has to be negative. Now, I think it's going to be the 6 that's negative because then 12 times minus 6 is minus 72. But 12 plus minus 6 is 6. So those are the two numbers. So remember, we split the middle term into those two numbers. So the 6y becomes 12y minus 6y using the two numbers over here. And remember, we still need the y's because 12y minus 6y simplifies to 6y, doesn't it? So we still need the y there. And then we copy over these other terms at the start and the end. And then we use something called pairwise factorisation. So we factorise the first half and the second half. What's common to 9y squared and 12y? Well, 3y is common. So 3y, and what's the bracket? Well, it's going to be 3y plus 4. Then remember, we leave the gap, and then we hope that we get the same bracket. If we don't, we've done something wrong. And then you think, well, what multiplied by 3y plus 4 is the minus 6y minus 8 in the expansion? Well, it's minus 2, and that does work. And then remember, we just use this thing in the bracket as the first bracket. And then anything outside that bracket, the 3y minus 2, is the other bracket. So we get that. So we've now factorised this expression. But remember that that y was never in the original expression in the first place, was it? We conjured up y. We said that y was equal to x plus 2. So at this point, we can substitute back the y for x plus 2. So I'm going to do that. I'm going to replace the y with brackets x plus 2. You need the brackets. And then the second bracket here, we've got 3 brackets, x plus 2, minus 2, like that. And then all we need to do is just tidy up in each bracket because we don't want brackets within brackets. So you can see you've got 3 times x here, which is 3x. And then I've got 3 times 2, which is 6 plus 6. We've still got that plus 4. And then the second bracket, we've got 3x plus 6 minus 2. And just tidy up further. 6 plus 4 is obviously plus 10. And in the second bracket, 6 minus 2 is obviously plus 4. And that is the final answer. Now, you might have wondered, could you have just like expanded this expression right in the first place and then just refactorise from there? And the answer is yes. But there might be more difficult expressions where that's not possible. And this kind of technique of using a substitution is the way forward.